The Lamprophyre and Lamproite. Lamprophyre and Lamproite. Okay, Lamproite. So these two rocks are ultramafic in nature. Okay, ultramafic in nature. So I will first go to the Lamprophyre, then we'll come back to the Lamproite. Okay, Lamprophyre. So Lampros means glistening. Okay, glistening, that means like चमक रहा है, ठीक है. Okay, so glistening and fires means porphyry. Okay, so glistening porphyries are present in Lamprophyre, so that's why it is called as Lamprophyre. Okay, Lamprophyre. So Lamprophyres are hypoabyssal mafic potassic rock and dominate by hydrosmafic silicate. So hydrosmafic silicates means amphiboles and micas. Okay, amphiboles and micas are there in Lamprophyre. So based on the presence of the hydrosmafic silicates. So the hydrosmafic silicate in case of Lamprophyre, the dominant minerals are what? Hornblende. Okay, hornblende, biotite. Okay, hornblende, biotite, and your uh, Muscovite maybe. Let me check. Okay, hornblende, biotite, orthoclase and plagioclase. Okay, orthoclase and plagioclase also there. So based on these four dominant minerals, what? Hornblende, biotite, potash feldspar, and plagioclase feldspar. Based on these four dominant minerals in Lamprophyre. Lamprophyre is what? Ultra potassic and ultramafic. Okay, so ultra potassic, ultramafic means potassium feldspar is there and mafic minerals are also there. So these are mafic minerals, biotite and hornblende, mafic hydrosmafic silicates. These are hydrosmafic silicates, and orthoclase and plagioclase are your potassic and sodic minerals. So based on these four contents, we have classified Lamprophyre into four types of rocks. Okay, four types of rock: minate, kersanite, vogasite, spessartite. Okay, minate, kersanite, vogasite, spessartite. So you can write down like this: minate is composed of biotite plus orthoclase. Okay, plus orthoclase. And minate, kersanite is biotite plus plagioclase. Then vogasite is hornblende plus potash feldspar, and spessartite. Spessartite is of hornblende plus plagioclase feldspar. You are getting the rhythm, na? Biotite plus orthoclase, biotite plus plagioclase, hornblende plus orthoclase, hornblende plus plagioclase. So, okay, minate, kersanite, vogasite, spessartite. Okay, these are the sequence. So you can remember easily. So this is the thing. These are the classification, the basic classification of Lamprophyre. Okay, Lamprophyre, four types of Lamprophyre. Apart from that, the feldspar mineral is confined to ground mass. Okay, feldspar mineral is confined to ground mass only, and the macrocrysts or megacryst, you can say, this is mainly hornblende and biotite. Okay, hornblende and biotite are mainly in megacrysts. Okay, and it shows essentially a porphyritic texture, and the grains are pandiomorphic granular. Okay, pandiomorphic means anyone? Euhedral grains. Panidiomorphic means euhedral grains. As we can see, Lamprophyre is a hypoabyssal mafic rock. Hypoabyssal mafic rock. That means it is the Lamprophyre melt is crystallized in a higher depth. So in a higher depth, there is a very high possibility of slow cooling. Na? So in very higher depth, slow cooling will be the result. So that's why the grains are very granular or larger grains, and the grains are well developed because slow cooling is going on. If there will be rapid cooling, the grains will be anhedral and glassy in nature. Okay. So tell me what about the porphyritic texture. About the porphyritic structure, what happens? What happens when the major component are crystallized? Okay, major component are crystallized as a coarse grain. Then the other small components, what happens? The small components they release the latent heat at a once. Okay, बहुत जल्दी क्या होता है, जो अदर कंपोनेंट्स, जो छोटा कंपोनेंट मतलब कम कंपोनेंट रह जाता है, वो बहुत जल्दी हीट रिलीज करते हैं. ठीक है, दैट्स व्हाई फाइन ग्रेन इज द रिजल्ट. जो आउटर साइड ऑफ मैग्मा होते हैं वो बेसिकली बहुत जल्दी क्रिस्टलाइज कर लेते हैं. ठीक है, जो इनर साइड होता है ना, वो बहुत ज़्यादा ग्रानुलर होता है. ओके. So plutonic intrusive, there is no volcanic equivalent of the Lamprophyre. No volcanic equivalent. Okay. So this is the classification of Lamprophyre: minute, carcinite, bauxite, spessartite. Apart from that, you can classify based on this sodium titanium amphibole, that is scanite, camptonite, monchiquite, and these are classified under alkaline, subalkaline. I am showing you that thing only. So calc-alkaline Lamprophyre, these are these four are calc-alkaline Lamprophyre. Okay, calc-alkaline Lamprophyre. What does calc-alkaline magma series पढ़ा ही नहीं ना? Okay, ठीक है. So these are calc-alkaline Lamprophyres: minute, carcinite, bauxite, spessartite. Apart from that, there are other two types of Lamprophyre. Okay, alkaline Lamprophyre, which is consist of syenite, camptonite, and monchiquite. Okay, and mellitic Lamprophyre. Okay, these are arnoite and polgenite. Okay, and these are mellitic Lamprophyres are not potassic in nature; they are ultramafic in nature. Okay, they are ultramafic in nature. ठीक है. So Lamprophyre occur as seals and dikes. There is nothing much to make you understand in the rock parts. Okay, apart from the petrogenesis, geochemistry, these things. The diamonds are also known from Lamprophyre, but this is very rare. Okay, there are very less examples about diamond occurrence in Lamprophyre. Okay, and about the geochemistry, they have high LRE. Okay, and basaltic level of HRE. This is the main thing. And as they are hydrosmafic silicates, that means the H2O content is high. Okay, H2O content is high. Apart from that, CO2 content is high. Chlorine, fluorine, SO3. You can go through this sentence. Which contents are high, which contents are low. Okay. So you have to just remember the LRE, the volatile content, and the HRE. Okay, RE things are main important. Okay, so you can see the minute. Okay, you can see here the minute. So what is the composition of minute? Crystal, these larger crystals are biotite. Okay, these are biotite. These are biotites. These are biotites. And all the white portion you are seeing, these are potash feldspars. These are potash feldspars. White portions. Okay. These are potash feldspars. You already know that the potash feldspar in Lamprophyre or plagioclase feldspar in Lamprophyre remains in a ground mass phase. Okay, ground mass phase. This is a classic porphyritic texture. You can see this is a larger grain surrounded by the smaller grains. Okay, porphyritic textures. Okay. So here you can also see biotite grains and finer VA grains. So XPL picture. Petrogenesis. Okay, petrogenesis of Lamprophyre. So what happens in petrogenesis of Lamprophyre? This thing. Okay, high depth of melting is required. Okay, high depth of melting is required, due to which mafic magma will be the result. Okay, mafic magma will be the result. First of thing this. Okay, first of all this thing. This. So mantle melted. Okay, a mafic magma is generated. Mafic magma generated. Now this magma should undergo differentiation. But to a very low degree. To a very low degree. To a very low degree. So what will happen if this undergoes a very low degree? So the potassic component, or the you can say the alkali components will not separated out from this magma. Okay, they will not separated out from this magma. If it go undergoes a very high degree of differentiation, then the granitic components will be out from the magma. Na? So there should be a low degree of differentiation, due to which the potassic components should remain in the magma. Okay, that's how we can get a mafic and potassic magma, which will result the Lamprophyre. Okay, Lamprophyre, where you can find the hornblende and potassic or hornblende plagioclase both are in the same rock. How this thing, this mafic magma should undergo a very less amount of differentiation. Okay, so this is the thing. If this magma undergoes a very high amount of differentiation, what will happen? Very high degree of differentiation, anyone? You can expect if the high degree of differentiation is done, is a mafic magma undergoes a high degree of differentiation, you can expect that a granitic proton is coming out from that magma chamber, and the magma chamber remained with a basaltic liquid. Okay, a pure basaltic liquid where olivine pyroxene are concentrated, but the felsic and calcic components are separated out. Okay, but if there is a low degree of differentiation, a very low degree of differentiation, then all the calcic felsic components are also available in that chamber. Okay, so that a Lamprophyre type of rock, or you can say a mafic potassic, okay, alkaline rock, a alkaline rock will be the result. Clear? Okay, so these are other things: lithophile elements, enrichment, high nickel and chromium, silica saturation, high potassium, sodium, volatile arrangement to support biotite and amphibole, lack of fractional crystallization, Lamprophyre develop lack of fractional crystallization. This thing indicates what? This differentiation, less differentiation. Okay, less differentiation. No differentiation, the process of differentiation. Okay, you know the process of differentiation. Can you say any mechanisms of differentiation? Yes, sir. Flow separation. Okay, gravity settling, fractional crystallization. Okay, fractional crystallization. फ्रैक्शनल क्रिस्टलाइज का अंडर में ये तीनों आते हैं ना, ग्रेविटी सेटलिंग, फ्लो सेपरेशन एंड योर filter pressing. Okay, filter pressing, these things come under fractional crystallization na. Okay, so fractional crystallization should be very less. So what this thing indicates? This thing indicates that if there is no fractional crystallization, there is not much amount of sodic or felsic components are separated from the magma. No, so all the sodic felsic components are in the present inside the magma, and the magma will be alkaline one. Okay. Okay. So Indian occurrence of Lamprophyre. Lamprophyre are in the Gondwana rocks, in the Gondwana basin. Very much of Lamprophyre are there presently. Okay, presently we can find high amount of Lamprophyre dikes in Gondwana basin. Okay, so tell available in Gondwana basins. Okay, Raniganj reported minette and leucitite of rocks. Some of these contain olivine and leucite. In Jharia coalfield, abundant types of olivine-rich petrotites, olivine poor minette, olivine vogesite, olivine phlogopite, and leucite Lamprophyre is there. Potassium argon of Gondwanic Lamprophyre range from 105 to 1 million year. What is the age of Gondwana? So potassium argon, yeah, this is the thing. So this is all about Lamprophyre. Okay. Anyone having any doubt, please ask. So there is not much of data about lamproids, but lamproids is a special kind of rock, unique rock. It is ultra potassic, okay, ultra potassic and poor potassic, okay, poor potassic and poor alkaline rock, okay, poor alkaline rock. These things important, these things are important. You have to start the writing, you have to start the writing with these things, okay. Like in Lamprophyre, you have to write Lamprophyre is a ultramafic potassic hydrous rich, your volatile rich and rock which contains hydrous mafic silicates as megacrest. This is the basic introduction of the rock, okay. You have to start these things from the you have to start the long question from these things, like lamproite is a ultra potassic, poor alkaline rock, okay. So so these are basic things, like who introduced. These are not important at all. Okay. So lamproids are important because they are found to be carry diamond like in kimberlite, because lamproite, the olivine bearing lamproite is equal to kimberlite, is equal to kimberlite. Okay. So that's why particularly olivine lamproids only carry diamonds as genochrist, as in case of kimberlite. Okay. So lamproids are ultra potassic, that means K2O by Na2O are greater than 3. For alkaline, Na2O plus K2O greater than Al2O3, and for potassic, K2O is also greater than Al2O3. Okay. So this is the introduction of Lamprophyre. Okay. So, sorry, lamproite. Well, there is not much of data present in lamproite, and lamproite is it basically contains micas. Okay, mica in phlogophyte, leucocyte. Okay, and olivine-rich lamproite only contain the diamond. Lamproites occur as dikes and seals like in your Lamprophyre. Okay, these are the basic minerals that are present in lamproite. These are very unique minerals, okay. These are very unique minerals. That's why the lamproite is classified as a other rock than that of kimberlite, okay. Lamproite is different from kimberlite because these minerals, titanium phlogopite, titanium potassium disterite, sodium and aluminum deficient leucite, these are very unique minerals present in lamproite, okay. सो इट इज बाकी ये सिमिलर है किसके साथ, किम्बरलाइट के साथ. इट इज इन इक्वली ग्रानुलर टेक्सचर आज इन किम्बरलाइट, ओके. इंट्रूसिव फॉर्म में रहता है, ठीक है. ग्रुप टू किम्बरलाइट के साथ ग्रुप टू किम्बरलाइट जैसे होता है, मतलब जेनेसिस जैसे होता है कि एनरिच्ड इन मेटासोमाटाइज्ड मैंटल, ठीक है. मैंटल मेटासोमाटिज्म पढ़ाया गया है, नहीं गया है? यू हैव टॉट मैंटल मेटासोमाटिज्म. Okay. So this is the geochemistry. This is ultra potassic. This is your pore potassic. Pore alkaline. Mg number is greater than 70. That means it is highly mafic or ultra mafic. Okay, ultra mafic. Low neodymium by neodymium content. What this thing indicates? Low neodymium by neodymium crystal. It is generated from a melt that is much more you can say less related to the primitive magma, okay, less relative to the primitive mantle, okay. That's why this is low in neodymium and neodymium. जो प्रिमिटिव mantle होता है उसके साथ लेस रिलेटेड है ये लैम्प्रोइड, ठीक है. एंड अल्ट्रा पोटासिक, see ultra potassic, poor potassic, that means the potassium content is very high. Okay, as the potassium content is very high, so neodymium and rubidium, what happens? Rubidium replaces potassium, very मतलब potassium को ही rubidium replace करता है ना, Rubidium only replaces potassium. Okay. Primitive magma is enriched in neodymium by neodymium, na? That is mantle component, na? Primitive magma is neodymium high रहेगा ना उसमें, वो mantle का direct source है. So see this one, what happens in lamproite? Lamproite is ultra potassic, poor potassic. That means the potassium content is very much high. Okay, and you know rubidium readily replaces potassium. Only potassium, I can say rubidium replaces potassium. Okay, strontium replaces calcium. So as the potassium content is very high in lamproite, so it is simple that the strontium ratio will be higher in lamproite because rubidium will decay the strontium, na? So rubidium content will be higher in lamproite and strontium content will be higher in lamproite. So high H2O content, incompatible elements enriched. Okay, incompatible elements enriched. So mode of occurrence strictly occur within continental intraplate areas within thick crust. जहाँ पे thick crust होता है वहाँ पर रहता है lamproite. Okay. In lamproite, due to low niobium and tantalum ratio, it indicated that subduction zone is likely. Subduction zone is the host area for lamproites. Okay, much of the lamproites are found in the subduction zones. Okay, so this low niobium and tantalum is the criteria of subduction zone. Remember that. Okay, sometimes it asks in the exams like your SSC group VI, SSC group VI का जो exam. So hydrous incompatible elements, each fluid generated in subduction zone must have played a role in geochemical composition. This is not much of importance. And these are dikes. These are dikes. Okay, seals. These are seals of lamproite. These are other classification of lamproite. You just go through this and don't memorize these things. Okay, these are not important. I have just given here so that you just know the names in mind, so that any question, if in future any question arises, then these things will strike your mind that yes, I have studied somewhere that these things undergoes in lamproite classification. Okay, so these are actually slides. These are not, these are dark, actually not processed by this software. No? I have given some in sections. Okay, see this one. This is phlogopite. This one. Okay, this is phlogopite, and this is calcium and rubidium. Okay, rubidium is present in here. Ca, calcium. Okay, these white things, and this is phlogophytic mica. Okay, this is lamproite, texture of lamproite. Okay, clear. So the source, basically the petrogenetic source is indicated as refractory Harzburgite source. Okay, Harzburgite mantle melting generates the lamproitic magma, which have high nickel chromium ratio and high alkali content also. Okay, this is the source of lamproitic magma. So there is not much of data about lamproite is available. Okay. And occurrences, very limited occurrences in India. One is Nuapada Khariar Basin and another is in Khadka in Bastar Cotton. Okay, very less occurrence in India. Okay, these things also I am not getting from any book. Okay, so I have to search on net where lamproite occurs in India. So I found these two places only. Okay, so this is lamproite. Anyone, please ask any doubt if you have any doubts. Many things you already know about anorthosite. Huh? I am just repeating these things that anorthosite is a raw plutonic intrusive, okay, intrusive gabbroic rock, okay, gabbroic rock, okay, gabbroic rock with greater than 90% of plage, okay, greater than 90% of plage. So it is a monomineralic rock. It is a monomineralic rock. Okay, and the plage is generally of labradorite type, generally of labradorite type. That doesn't mean always anorthosite which contain labradorite. Okay, labradorite type. And similar lunar anorthosites, the white part you see in the lunar na, in the moon, those are all anorthosite, and the black parts are basalts. Okay, so lunar anorthosites, these are enriched in bitonite. Okay, bitonite. Okay, these things, and these are generally limited to time and space. That is Archean and Proterozoic. This is the time, limited to time and space. You can first write that this is limited to time and space. Time and space. Okay. In case of time, this is limited to Archean and Proterozoic. In case of space, they are two types of actually anorthosite. We will go through that. And the major type actually associated with LMIs, large mafic layer mafic intrusions like Bosveld, okay, scared guard, still water, okay. So here anorthosites are associated. Other things, other type like your non-stratified type anorthosite or group 2 anorthosite. Group 2 anorthosite is very limited. Okay. And the major thing is there is no volcanic equivalent of anorthosite. Okay, there is no volcanic equivalent. No volcanic equivalent of anorthosite. So no volcanic equivalent of anorthosite. What is the problem actually? We cannot directly study the anorthosite behavior. Na, like in case of granite, we have rhyolite, so we can directly study rhyolite, so we have much of data about granite. But in case of lamproite has also no volcanic equivalent, we have less data. Okay, like that in case of another site, there is no volcanic equivalent, we also have less data. We only have the hypothesis. Okay, theories, no, not proven. Okay, so the rock which are not having any volcanic equivalent, the problem arises is that we cannot study directly. We cannot study directly the behavior of the that magma. Okay, like anorthositic magma or lamproitic magma, we cannot study directly. Okay, uh, like decipher the informations from the already consolidated rock. Okay, and this is also present from the very past like in Archean or Proterozoic. So there are many changes in temperature, pressure condition, earth condition. So after these changes we have to study this. Okay, so we cannot get much of information so that we can describe these rocks. Like in granite, we know how this type of rocks generate. Okay, so this is the anorthosite, no volcanic equivalent of anorthosite, and due to excessive accumulation of europium, so it shows positive europium anomaly. Okay, excessive accumulation. Plagioclase है positive europium anomaly दिखाएगा. Okay, now these are the basic things. Then we are going to the slide. देखते हैं क्या होता है. The felsic minerals are associated with high temperature mafic minerals. This is the thing. The felsic minerals are associated with high temperature mafic minerals. Okay. The plagioclase are associated with mafic minerals because it is the total anorthosite. Major of the anorthosites in the world are associated with layered mafic intrusions. Okay. So that's why the minerals, plagioclase minerals, are also associated with the mafic minerals. Okay. That is it is called. That's why it is classified under ultramafic rocks. So highly felsic in nature, they are location in continental areas. They are granitoid rocks. The felsic mineral, however, is a calcic plagioclase. Okay, bitonite type, a labradorite type generally. So this is the anorthosite problem. Okay, this is the anorthosite. What is the anorthosite problem? There is no volcanic equivalent. Okay, there is no volcanic equivalent. This is a major problem, anorthosite problem. Sometimes it asks what is the anorthosite problem. So these are some things that arises many problems in anthracite. So first of all, there is no volcanic equivalent to study. Mode of emplacement does not reflect common magmatic intrusion. जो common magmatic intrusion जैसे होता है ना, सो अनोथोसाइटिक प्लूटन अगर कुछ है लाइक इन ईजीएमबी, ओके ईजीएमबी, सो ईजीएमबी में क्या हुआ है, अनोथोसाइट ऐसे है, अनोथोसाइट आर सच दैट दे आर लाइक प्लूटन्स, ओके अनोथोसाइट प्लूटन्स आर देयर in case of EGMB. So, but in case of Bosfeld, they are crystallized and separated. Okay, I'll give the the image interpretation of that anesthetic crystallization. Okay, we'll study about that. So in case of EGMB, na, the hosted anthracite is like Pluton type. So mode of emplacement is like not definite yet. Like we know in case of granite, granite is intrusive in nature. Okay, intrusive in nature and always occurs like a big laccolith or yeah, your batholith. Okay, granitic batholith. But in case of anorthosite, it is not fixed. Massive type anorthosite is restricted in time and space. Massive type is very limited. Massive type generally we get a layered type, stratified type. Okay, this is Bushveld, Stillwater, Skarsgård. Okay, all of the anorthosite are major anorthosites are stratified type. Okay, but there is also a massive type in like in one place. Let me see that name. Uh, Okay, it's Adirondack Massif, USA. Okay, Adirondack Massif, USA. Here, massive type of we get the massive type of anorthosite. Okay, we'll go to that slide again. Plagioclase has bimodal size of distribution in massive anorthosites. Okay, in massive anorthosite, what happens? Plagioclase occurs both as like your finer grains and coarser grains. Okay. So plagioclase occurs both as final grains and coastal grains, bimodal site distribution. So this also creates a problem to study the study the crystallization behavior. Okay. So also many anthracite contain OPX. I am highlighting this point because anthracite problem is a good question. Okay, many times it has already come in the previous GSI mains papers. What is anthracite problem? So you have to write down these 5 6 points and describe this like I am describing. Na? So you have to describe this. So a variety of most evolved rocks like quartz, syenite, quartz, monzonite, hypostene granite is associated with anorthosite plutons. So these rocks are also associated with anorthosite plutons. So this makes a complication that how these rocks, quartz, syenite, quartz, monzonite, these are highly acidic and felsic rocks, na. So how these are associated with also associated with anorthosite. This also creates a problem. So these problems are not solved yet. Okay. So this is anorthosite problem. Okay. So anorthosite can be classified like in 6 types, but we generally classify into 3 types. You just like read these 6 types. That is Archean anorthosite proton, Proterozoic massive type, so 100 centimeter to 100 meter layer mafic intrusions, thin cumulates, small intrusions, and lunar Hylian anorthosite. These are basically 6 wide type of anorthosite, but we just classify this into 3 types. Okay, this is anorthosite. You can see these are the plagioclase and the snowflakes anorthosite. This is called as snowflake anorthosite. Okay, snowflake anorthosite, because these plagioclase are of in the because these plagioclase are in the snowflake shape, na. So this is plagioclase. देखो how much of black color is there. मतलब इतना plagioclase होने के बाद greater than 90% plagioclase होने के बाद ये white नहीं दिख रहा है. It is not in the white color. Okay, it is in the melanocratic side. Okay. So snowflakes anorthosite. This is also a example, also an example of anorthosite. Okay. So classification, basically there are 3 types of anorthosite. Okay, we classify as group 1, group 2, and group 3. So group 1 anorthosites are widely available. We can find it everywhere, not everywhere, like major of the anorthosites are group 1 anorthosite. They are also called as stratiform type or layer type. Okay, because they are crystallized in a sequence like they are stratified. Okay, they are associated with large mafic intrusions or layer mafic intrusion. This is Boswell still water, or you can say your scare guard intrusion. Okay, subordinate mafic minerals are present. This is the thing. The characteristic thing is it shows cumulus to intercumulus texture. ओके एंथ्रासाइट जो तुम्हारा होता है ना स्ट्रैटिफॉर्म टाइप, ये क्यूमुलस टू इंटरक्यूमुलस टेक्सचर होता है, क्योंकि वही होता है जब पूरा अंदर में एक माग्मा रह जाता है ना, तो वो धीरे धीरे क्यूमुलेट्स सब क्या होता है, दिस क्यूमुलेट्स सेटल डाउन इन द बॉटम पार्ट ऑफ द settle down in the bottom part, settle down in the upper part of the chamber, because this magma chamber is highly mafic in nature, so these plagioclades will crystallize first. No, these plagioclades having lower melting point, so this will crystallize first. So we'll go through this melting model, crystallization model in the next slide. Okay, I'll tell you in detail. Okay, so cumulates, what is a cumulates? The cumulates are formed and go upward, rise upward and settle here and form a layer. Okay, they settle down by layers. So layered type of anthracite is formed. Okay, so going to the group 2, group 2 are domical to multidomical shape, not stratified. They are called as massive type. Okay, they have epidiomorphic or alatromorphic texture. Okay, this is epidiomorphic or alatromorphic texture. They are divided into two types: orogenic pluton type, like in EGMB, this is available in EGMB orogenic pluton, and gravity stratified type. Okay, gravity stratified doesn't mean stratified, or to be precisely stratified. Okay, gravity stratified means you can say the layers are, those layers are not prominent in gravity stratified type. Okay, so this is group 2, and in group 3 is also called as lunar anorthosite, bitonite to anorthositic in composition, highly calcic in nature, Archean age restricted to Archean age. Okay, and associated with chromite, and these are highly deformed as they are Archean, they are from Archean age, so they are highly deformed in nature. So these are three groups of anorthosite: 1, 2, and 3. Group 1 is known as the stratified type, group 2 is known as the massive type, and group 3 is known as the lunar anorthosite. Group 1 shows a cumulus to intercumulus texture, group 2 shows a epidiomorphic to allotromorphic texture. Okay. So geochemistry you already know that it shows a positive europium anomaly. Okay, and anorthosite equally enriched in HRE. So जो chondrite होता है, chondrite value से वो HRE equally enriched होते हैं, but in case of LRE they are 3x to 10x उसका enrichment होता है. So can you draw the diagram and send me? Saying that anorthosite are equally enriched in HRE. So if I am drawing this is the one value. Okay, this is the one value. So it will be similar with the chondrite. Okay, the HRE part. Okay, yeah, I am considering this is a europium. So this is a HRE part. This will be similar with the chondrite. Okay, that means it is equal to the 1. Then it shows europium anomaly. So I am creating a peak. Okay, then it shows it is slightly enriched 3x to 10x in LRE values. So this is 1, this is 10. Okay, logarithm scale. So you can draw like this from 10 or from middle of the 10. Okay, you can draw like this. Okay, everyone getting this now? Or the diagram is very small. Okay, you can draw like this 3x to 10x. So between 1 to 10, you can draw this thing. So the diagram will like this. This is positive europium anomaly. This is equally enriched in HRE. Okay, and the LRE is slightly enriched. Okay, so many of you are done correctly. Very good. Okay, so this is the diagram. Okay, this is the diagram of your anorthosite RE pattern. Okay, RE pattern of anorthosite. RE pattern of anorthosite. Okay, so we are getting to the petrogenesis model. We are getting to the petrogenesis model. So this is the description. The description. I am going directly from the single diagram. Okay. So what happened? See what happened. First of all, what happened? A magma pluton came from the uprised from the mantle. Okay, a magma pluton uprised from the mantle and underplated over the crust. This is the crust, this is the mantle. This is a petrogenesis model. Okay, this is not true for everywhere. There are many models about anorthosite origin, but this is the best model. This is the best model and easiest model. Okay, so this is the base model. This is followed by every book, almost every book, and also if you will follow Inter, you will find 2 or 3 models of formation of anorthosite. Okay, now this is easy to understand, and this is also like followed by every book. Okay, so a pluton came and it is underplated under crust. Okay, now what will happen? It will start crystallizing. It will start crystallizing. Na? So, as you know, the felsic minerals have a lower melting point. A lower melting point. So, the felsic mineral will crystallize first. So, the felsic minerals are crystallizing first. And after the crystallization of felsic minerals, and what will happen? The felsic minerals will go upward. Okay, rise upward because the remaining melt is of mafic composition, and mafics are of high density. Okay, mafics are of high density. So these are all mafic minerals. Okay, these are all mafic minerals, and these are all plagioclase or felsics, you can say. Okay, now the stratification begins. See how they are stratifying. So there are many nucleation points. Okay, when the plagioclase is crystallizing, it is going upward and making a layer. Okay, after that, and as it is a large mafic intrusion, the cooling process is very slow, na? So very slow. So what will happen after that? Some crystallization, some crystal of if some crystal of mafic mineral is crystallized, then they will settle down because of high density, and the plagioclase will be gone upward, or we can say another thing. Sorry, मैं थोड़ा गलत बोल दिया. ओके, थोड़ा गलत गलत बोल दिया, उसको करेक्ट करते हैं. First the mafic minerals will crystallize ना. Mafic minerals will crystallize first ना, because they have higher melting point. So जब ठंडा होगा तो फर्स्ट माफिक मिनरल क्रिस्टलाइज होगा ना. वो थोड़ा गलत बोल दिए. ठीक है. So what will happen? The mafic minerals, when the mafic minerals will crystallize, they have high density, so they will settle down first. Okay, they will first settle down. They have high density. Okay, so they will first settle down to the bottom part of the pluton. After that, when temperature decreases, the already this part is getting enriched in felsic component. The upper part is getting enriched in felsic component. Okay, already the upper part is getting enriched in felsic component. Okay, because the mafic minerals are settling down after crystallization. Na? So when time comes that they are all separated. Okay, and when the temperature declines, what happens? Plagioclase also starts some crystallization. Okay, along with some liquid, along with some mafic liquid. See, कुछ माफिक मिनरल, ज्यादा से ज्यादा माफिक मिनरल यहाँ पर क्रिस्टलाइज हो गया है. ठीक है, बट अभी भी कुछ माफिक लिक्विड बाकी है, और साथ में जो लिक्विड है वो ऑलरेडी फेल्सिक हो गया, क्योंकि ज्यादा से ज्यादा मिनरल क्या हो गया, नीचे सेटल डाउन हो गया. नाउ दिस लिक्विड व्हाट हैपेंस? नाउ द लिक्विड goes upward. Okay, rises upward due to very low density. ओके फ्रॉम दिस प्लूटन। ओके, तो इसका डेंसिटी बहुत घटता गया ना, इस लिक्विड का डेंसिटी बहुत कम होता गया। ऑल द माफिक मिनरल सेटल डाउन, सब डेंसिटी नीचे चला गया, तो इसका डेंसिटी कम हो गया, तो ये धीरे धीरे क्या होगा, वहां से निकलता जाएगा। कहाँ से? वो मैग्मा चैम्बर से निकलता जाएगा। और वो मैग्मा चैम्बर में उसमें क्या है, यहाँ माफिक मिनरल था, तो कुछ माफिक मिनरल रह गए हैं वहां पर, कुछ थोड़ा बहुत माफिक मिनरल, माफिक फ्लूइड रह गया है, और साथ में एक फेल्सिक और कैल्सिक फ्लूइड है। ठीक है, तो ये दोनों जो होगा, ये जो प्लूटन्स है, ये फिर ऊपर राइज करेंगे, ऊपर राइज करके जाके सेटल होंगे। ठीक है, जाके सेटल होंगे। दिस विल गिव यू द अनॉर्थोसाइट प्लूटन्स। Anorthosite plutons. Okay, if this plutonization is not occurring, then this thing will settle what, in LMIs, layered mafic intrusions. This thing will create what, anorthositic layers. Okay, stratified type of anorthosite. If these plutons are if plutons are escaping from this magma chamber, these are pluton types. These are pluton type anorthosite, or you can say massive type anorthosite. Okay, this is the thing. Everyone understood, or I have to tell once again? Sorry, anorthosite. Okay, anorthosite petrogenesis. It is about anorthosite petrogenesis. Okay, you can read this, and these slides are there also. You can follow this slide. The same thing is written. Okay, the same thing is written. Okay. Okay. So this is the mineralogy. Anorthosite commonly contain megacrystal of aluminous bronzite. Al2O3 indicate crystallization at high pressure. Okay, these are general things you can go through. This is nothing much to make you understand. Okay, so general things you can go through this. Okay, just read this, you will get. So Indian occurrences hosted in EGMB, you know already. North Bihar Chotnagpur massif is also an anorthositic massif. Sargur belt में है anorthosite. पूरी बालूगांव रंभा बानपुर ये डिस्ट्रिक्ट इस जगह पे anorthosite है. The largest anorthositic complex, largest anorthositic complex may be yes, the largest anorthositic complex. And can anyone name the largest anorthositic complex? So Bolangir massif. Next is your economic importance. It is used in paper manufacture. यहाँ पर कैटलिस्ट इन ऑर्गेनिक रिएक्शन में भी यूज होता है, एंड सीमेंट इंडस्ट्री में it is also used in cement industry. Okay, these are the economic importance. So this is all about anorthosite. If anyone are having any doubt, please ask.